chemical reactions of aromatic amines, aniline, electrophilic substitution reactions. Aniline undergoes electrophilic substitution reactions due to plus or effect. Chemical reactions of aromatic amines, electrophilic substitution reactions of aromatic amines, benzonamine or aniline. Aniline undergoes electrophilic substitution reactions due to plus or effect, positive resonance effect, otherwise known as mesomeric effect. The unshared pair of electrons on nitrogen, the unshared pair of electrons on nitrogen or in conjugation with the conjugated system, otherwise known as benzene ring. And these electrons are traveling towards the benzene ring because of the more electron withdrawing effect of benzene ring, due to that is known as plus or effect or mesomeric effect. The migration of unshared pair of electrons from nitrogen atom of the group towards the benzene ring conjugated system is called plus or effect or mesomeric effect. And developing positive charge on nitrogen and the shift of pi electrons, these are known as pi bonds. 1, 2, 3 pi bonds are there. Pi electrons, shifting of pi electrons takes place. As such, electrons are more at second position or ortho position, fourth position or para position, and sixth position or ortho position. Once again, we will regenerate the structure of aniline exactly opposite to the first structure. Here, the bonds are in clockwise direction, pi bonds are in a clockwise direction. Here, they are in anti-clockwise direction. And what does this structure shows? This structure shows that electron reach centers are second, fourth, and sixth. To these centers, electrophile, electron deficient species may be X plus halogenation, NO2 plus nitration, SO3H plus sulfonation may take place, and those particular groups may be attached in the second or fourth or sixth position. Now let us go to the examples of electrophilic substitution reactions. The various electrophilic substitution reactions are, the first one is bromination. Aniline is highly reactive, very highly reactive due to the presence of unshared pair of electrons on nitrogen. The unshared pair of electrons on nitrogen makes aniline quite active and undergoes bromination in aqueous conditions. The 3 hydrogen atoms at ortho position, second position, fourth position, and sixth position reacts with 6Br total, 6Br, 3Br and 3H. 3Br and 3H gets eliminated as 3HBr. Remaining 3Br attached to the second, fourth and sixth position. We will get 2,4,6 tribromaniline, a white precipitate. This is an example of, this is a test for aniline. Aniline undergoes bromination in aqueous medium in the presence of polar solvent. This bromonium, like halonium, it is bromonium, it is halonium, it is the electrophile, electron deficient species. And substitution of a weaker electrophile, H plus, by means of weaker electrophile. It is not nucleophile, it is electrophile. Weaker electrophile by means of a stronger electrophile is a kind of electrophilic substitution reaction. Aniline is quite active due to the presence of unshared pair of electrons on nitrogen, undergoes electrophilic substitution reaction at second, fourth and sixth positions. The weaker electrophile at these 3 positions, H plus, substituted by means of stronger electrophile 3Br plus in aqueous polar solvent medium, and total 6 Br, 3 Br with 3H, 3HBr, remaining 3 Br attached to 246 position, 246 tribromoaniline, a white precipitate, a test for aniline. Next one is nitrate. Next one is this is here. Aniline is quite active. That's why we are getting a polysubstituted product. We want to get a monosubstituted product. That means bromine attached to only one position, not at three positions. What we have to do? The reactivity of active. I told you already, aniline is quite reactive in nature due to the presence of unshared pair of electrons. That's why we are getting a polysubstituted products. This activeness must be decreased. How to decrease the activeness? The activeness must be decreased is when you add acetic anhydride. I told many times, acetic anhydride, how to prepare. Have patience and see all the parts. Acetic anhydride, ethanoic acid or acetic acid, ethanoic acid or acetic acid. What will happen here? I told many times I told OH, OH and H gone, OH and H gone, CH3CO one time and CH3CO second time, and this O is in common. You will get acetic anhydride and aniline. Aniline, this is aniline, reacts with acetic anhydride. Acetic anhydride, 2 ethanoic acid molecules, water is eliminated. CH3C double bond O, CH3C double bond O, one O is common here. In the presence of pyridine, this is called acetylation. When you use acetic anhydride, it is known as acetylation. When you use acid chloride, this is CH3COCl. When you use CH3COCl, it is called acylation. It is called acylation. When you use acetic anhydride, acetylation. Acid chloride, it is acylation. Then what will happen? The reactivity is decreased by acetic anhydride. 1AH here, CH3, C double bond O, 1AH gets eliminated as CH3, COOH, that is called ethanoic acid. Ethanoic acid. Left behind is benzene ring. 1AH gone, NAH, C double bond O, CH3. This is known as N-phenyl ethanamide or N-phenyl acetamide. Another common name is acetanilide. The reactivity is controlled. Now. After this, how it is controlled? This is the same thing. NaHCOCH3. NaHCOCH3. You see here. NaHCOCH3. What will happen here? It forms. That is a control. How it is controlled? This unshared pair of electrons comes here. This goes here. That means this will come here, means nitrogen will get positive charge. Nitrogen will get positive charge. This is positive. And the next one, what will happen? See, double bond O, see, single bond O, this resonating structure I am drawing here. This unshared pair of electrons will go there. You will get N, unshared pair of electrons going there, positive, NaH, one bond will migrate here, C single bond O minus and CH3. I told you, due to unshared pair of electrons, this aniline is quite active. Unshared pair of electrons, its reactivity is controlled by shifting the electrons. Now nitrogen is getting the positive charge due to resonance. These two are resonating structures. Now this is acetanilide. Undergo bromination. Bromine will be attached at para position or ortho position. Now this in the presence of water. This will react in the presence of water. In the presence of water, what will happen? CH3CO, CH3CO, CH3CO and OH left behind as CH3COOH. CH3, C double bond O, OH. This H will be attached here and you will get 2 bromoaniline. 2 bromoaniline. You just look at this. This is polysubstituted product is due to the quite reactive nature of nitrogen having unshared pair of electrons. We want to have monosubstituted product. This reactivity is controlled. Aniline reacts with acetic anhydride, one hydrogen atom, CH3C double bond OO, CH3COOH, left behind is NH, COCH3. And the reactivity is controlled all by shifting the electrons here. You will get double bond, then C, these electrons will shift here, C single bond O minus and CH3. See, these electrons will be shifted here, means you will get double bond. Then C, then this bond will be shifted here, O minus CH3. Nitrogen getting positive charge. Earlier, nitrogen is quite active due to unshared pair of electrons. Now its reactivity is controlled due to the development of positive charge. Now it undergoes bromination. Bromine is attached here, para position, and this is acetanilide. Acetanilide with a positive charge on nitrogen, bromination. 4-bromoacetanilide, para-bromoacetanilide reacts with water. What will happen? CH3, C double bond OOH, H will be attached here, and ethanoic acid is eliminated with the regeneration of aniline. 4th position bromine, para-bromoaniline or 4-bromoaniline.